All right, so there are some things that can arise, and this is an example of one that there's something else that we'll have to contend with here. The u substitution, though, is pretty straightforward. The u is going to be the 9x minus 1, right? U is 9x minus 1. And so we also need du. Du would be the derivative of that, which would be 9 times dx. Divide by 9, that gives me my dx. So du over 9 is what I would replace dx by. Okay? All right, well, the 81x, let's leave that for the moment. The 9x minus 1 to the 50th, that's, I'm going to call that now u to the 50th. That was my u substitution. And then dx is du over 9. Okay. Well, a little bit of cancellation happens. The 81 can cancel by 9, so I'm left with 9x u to the 50th du. But we still have a problem, don't we? Previously, when we did that cancellation and all that u substitution, we wiped out all the x's. In this case, we did not. There's still an x remaining even after we did our cancellation, after the u substitution. Well, the way we can fix this, so if you have an x here, the way you can fix it is go back to your original equation, original substitution equation. So what I need to do is figure out what I can replace x by in terms of u, because it's still left over here, but it needs to be in terms of u for this to work. I need everything to be u's. And so let's go back to the original equation. If I solve this for x, let's see what that gives me. So the original equation, substitution, was u equals 9x minus 1. So to solve that for x, I would add 1 and then divide by 9. So u plus 1 over 9 is x. So that gives me a way that I can write x over there in terms of u. So now let's make that substitution, if you will. X is u plus 1 over 9. And then we have e to the 50th du. So again, we get some cancellation. The 9's cancel. And so we wind up with just u plus 1 times u to the 50th du. Now that looks like it's still a problem because it's multiplication. And as we know, the antiderivative of multiplication is not the antiderivative times the antiderivative. However, this problem is now much easier because do you notice what I can do that I couldn't do previously? Back here, this is 9x minus 1 to the 50th. I can't distribute the 81x here because that's to the 50th power. This is a totally different power. Unless they're the same power, in that case you can't do that. I can't distribute here for various reasons. However, what's blocking me from distributing this? That's okay, isn't it? I can do that. So I couldn't distribute here, but now I can distribute here, you see. So I kind of switched it where I could distribute. That's just u to the 50th, 51, plus u to the 50th, right? U to the 50th times u to the 1st is u to the 51st, and then 50th. Aha, so now I don't have multiplication once I distribute there. It's just antiderivative power rule now, it's just addition. So that'd be 1 over 52, u to the 52, plus it'd be 1 over 51, u to the 51, plus c, this is indefinite interval. And then just last but not least, go ahead and change those back. Change the u's back to 9x minus 1 now. So it'll be 1 over 52, 9x minus 1 to the 52, plus 1 over 51 times 9x minus 1 to the 51 plus c. Yes? Probably not what we would have guessed when we started that out. Maybe the 51 power we could have guessed, but it actually winds up being that. So anyway, okay? So yeah, sometimes, so yeah, if you get, once you simplify here, you still got an x, you can go back to the original equation. Well, an x one. And that. Let's try this one. Similar thing happens here. What do you think the u is going to be here? Well, we go ahead and write it up. This is going to be 1 plus x squared to the 1/2 times x cubed dx. And again, unfortunately, just point out here, that doesn't got me thinking, well, just simplify that. Unfortunately, you can't do that. The square root of 1 plus x squared does not equal the square root of 1 plus the square root of x squared. So we have to leave that. And so it's just 1 plus x squared to the 1/2 power. And so that pretty well lines us out there. It tells us that the u here is going to be, squeeze this in a little bit. Across, a little more obvious. Yeah, the u is going to be the 1 plus x squared, which would make du, so go ahead and get the du also. The derivative of that, which would be 0 plus 2x, so it would be 2x times dx, and then divide by the 2x, you get du over 2x, is your dx. That's what I'll substitute for dx. So what have I got? I've got u to the 1/2. The x cubed, haven't done anything yet with that. We will. And then dx is du over 2x. Okay? What happens? A little bit of cancellation happens. The x will cancel into the x cubed and leave me an x squared. So I have, let's write it this way. So I've got 1/2 u to the 1/2 x squared du. So I pulled that 1/2. It usually, whatever fraction you have here pulls out front here. Usually how they do it. But I still have the small problem, don't I? I still have x squared. So like this one over here on the left, when I did my cancellation, substitution and cancellation, I still have an x squared in this part of it. Well, I need it all in terms of u, so go back to the original equation. U equals 1 plus x squared. So can I write that in terms of u? Just subtract 1 here. And u minus 1 is x squared. I mean, you can take it down to x, but we actually need it to be x squared, don't it? X squared is u minus 1. So I can substitute u minus 1 for x squared over there. So I have 1/2 u to the 1/2 times u minus 1 du. Which is still a problem. I still have multiplication, which that's what I started with. We're trying to work our way out of that. Well, previously I can't multiply that easily anyway together. But this is not too bad. If I go ahead and distribute now that 1/2 u to the 1/2, that'll be 1/2 that's u to the 1, so I'd add those exponents. That'd be 1/2 u to the 3/2. And then 1/2 u to 1/2 times -1 is just minus 1/2 1/2. So now I have it. It's not multiply, it's just subtraction. And I can do subtraction antiderivatives like this all day long. So the antiderivative here would have 1/2. Let's see, the new power, add 1 to get the new power. 3/2 plus 1 would be 2/2, so it'd be 5/2. Reciprocal would be what I multiply front by. Minus then 1/2 this new power, so I'd have 1/2 plus 1 be the new power here, which would be 3/2. 2/3. 3/2. Let's see. All right, that'll be 2's will cancel, so I have 1/5. And then u is, back here is 1 plus x squared, so it'd be 1 plus x squared to the 5/2. 2's cancel there also, so it'd be minus 1/3. U is 1 plus x squared. That's to the 3/2. Let's see. Okay, now, let me make this point with you. So that's, in both of these cases here, when I did the cancellation, I had an x, or an x squared, I had something involving x still remaining. And it was over here. Now let me show you this one. Try to keep these two up here. But let me show you a little problem, what else we can run into. Let's say I have the integral of x sine of x cubed dx. Okay, so this one we're going to have a little different problem. All right, so it's obvious u would be x cubed, du would be 3x squared dx, and so divide by the 3x squared, and so my dx is going to be du over 3x squared. All right, so make those substitutions. X cubed, x I'm going to leave for the time being. X cubed is u, so it'll be sine of u. And then dx is du over 3x squared. All right, well, what happens differently in this one is, notice, this x will cancel into that x squared and leave me an x. And so basically what I have is, let's say it's 1/3 sine of u du over x. That's a problem. Yeah, the reason this one's different than the previous two I still had an x or an x squared after I did the substitution. The problem is where this x occurs. This x occurs, it's still, if you will, in the denominator of the du. What that amounts to is you can't do this one. Cannot be done by u-substitution. If you have still, when you do the cancellation, if you still have an x, some expression involving x, after you cancel everything, if you still have a variable in your denominator of du, like we've been doing it, you can't do this with u-substitution. If you have an x, and these x's weren't in the du, you know what I'm saying? I canceled, well, this was probably a better example. I canceled this x out in the denominator of du, and that left me an x squared, but it's not in du, as far, from the u-substitution. So if you have an x left in the denominator of the du, that's a signal. You can't use the u-substitution, okay? And still have denominator of du. Kind of how I explain it. What it amounts to is you need this to be able to cancel out somewhere, somehow over here with x's, like it's always done on the previous examples. Yeah, this x canceled out. So I always need that to cancel out. I don't need something left over as far as an x goes. I mean, if you have a variable, that's, I mean, if you have a number, that's okay. But a variable in that part, that's no good. It's what it does is just kind of, you won't ever get anywhere. You just keep going in circles. I mean, we could try to, use the cube root of u, but we wind up just back where we were. So it doesn't quite work out this thing. It doesn't work out at all. So anyway, just want to make that point. I don't know that there's any in our assignment like that, but you need to be aware that u-substitution doesn't always work. It won't work on this one. This is one example where that wouldn't work. All right. Now,